continue looking at Chapter 4 by looking at the shape of frequency distributions as well as displaying and analyzing data. When you have to discuss the shape of a graph or display, you'll always look at distribution first, discussing the symmetry or the skewness. After that, you will then discuss the number of modes and the smoothness of the graph. When we look at distribution, a graph can either be symmetrical or positively skewed or negatively skewed. A symmetrical graph looks similar to this. Here we can see a symmetrical histogram as well as a box and whisker plot. A graph shaped like this is also called bell-shaped or normally distributed. A positively skewed graph shows a tail towards the right-hand side and is also called skewed to the right. You can remember that by saying the tail points towards the positive bigger numbers on the number line, and that's why we call it positively skewed. Negatively skewed, similarly, the tail of the shape points towards the negative side of the number line, and that's how we can remember that it's called negatively skewed. The skewness of a graph also gives us an idea of where the mode, the median, and the mean are situated. In a symmetrical graph, we'll have a mode, a median, and a mean that are close to each other or equal, where in a positively skewed graph, the mode will be there where the frequency is the highest, and the median and the mean will be situated to the right of that. In a negatively skewed graph, once again, the mode will be at the highest point where the highest frequency is, and the median and the mean would be towards the left of that. The number of modes, unimodal means there's one score with a higher frequency than the other, so it's only one mode. When you have two modes, it's called bimodal or multimodal with more than two modes. A smooth graph means there are no breaks and no jagged sections in the graph. And not smooth mean there are either breaks in the graph or specific vertices where the graph is jagged. When we are asked to discuss whether there are outliers in a set of data or not, we always need to justify this by calculation. These formulas are on the formula sheet, and it's useful if you know that they are there, where they are, and how to use them. This is an example of a stem and leaf plot. If we are asked to discuss outliers in this set of data, we're first going to calculate which scores would be considered outliers. We've got 23 scores here. So the median is score number 12, which is 96. We don't really need the value of 96, but we need to know which score it is. The lower quartile in the lower half of the scores is score number 6, and that's 88. The upper quartile is score the 6th score in that upper half, and that is score 103. That gives us an interquartile range of 103 minus 88 is 15. Now we're going to use the formulas from the formula sheet. The lower quartile, 88, minus 1.5 times the interquartile range, gives us a value of 65.5. That means any score less than 65.5 would be considered an outlier. So for this set of scores, 50 will be considered an outlier as it is less than 65.5. We can also say any scores more than the upper quartile plus 1.5 times the interquartile range. So any score more than 125.5 can be considered an outlier. Therefore, 113 and 116 cannot be considered outliers because they are not more than 125.5. Displaying data, we'll just quickly look at the different methods that can be used to display data. A column graph can be used for a single set of data or more than one set and to compare that easily. A bar graph, very similar, we just have horizontal bars and not vertical columns. And a line graph, that's very applicable for continuous data. For all of these, it's important to know you always need a title, you need to label the axes, the vertical axis need to start at 0 and have an even scale. If you have a start with that's not even to the other gaps, you need to indicate it like that, but it's preferable just to have an even scale. The fourth method is a sector graph. For this, you need to be able to calculate the angle that the size for the netball sector has to be, or cricket, or whatever one. So you'll take the quantity of players who chose netball divided by the total of players surveyed times 360 degrees, because a full circle takes 360 degrees. You sometimes also need to be able to calculate the percentage players for netball, cricket or soccer, which is the same fraction as before, multiplied by 100 to get it as a percentage. A divided bar graph is similar to a sector graph, just in a horizontal rectangle instead of in a circle. Calculations of percentages, calculations of what length you'll use for that would be exactly the same as we've done before. The fraction of that times the length of the bar, or the fraction of that times 100 to get a percentage. Frequency histogram and polygon we have discussed in a previous lesson. Just a reminder that no gaps between columns, half a column gap at the start, and dots for the polygon in the middle of each column. Cumulative frequency histogram and ogive, similarly done in a previous lesson. Just a reminder that the dots would now be in the top right of each column. A dot plot and a stem and leaf plot. Make sure that you understand the working of a double stem and leaf plot, where the stem goes for the right hand side, for example, boy's height 153 and this girl's height 154. A radar chart, once again, very useful for either showing a single set of data or more than one with very good comparison. An area chart, very good for comparing different sets of data. It shows cumulative totals. So this 53 shows the total of Series 1 and Series 2 plus Series 3. If you then want the total for Series 1 only, you will have to subtract to find that individual score. Two-way tables, another method how to summarize and display data in more than one way. When you analyze data, it's important to read the data from the graph and refer to specific variables and the specific numbers from the graph in your answer. Secondly, it's also important to link that information to apply it to the specific question asked if necessary. And that's the end of this lesson, and you can now continue to the homework exercise.